Hello. In this video, we are going to learn about asymptotes of rational functions. So, a rational function is the quotient of two polynomials. So, you have a polynomial on the top and then being divided by a polynomial on the bottom. They're going to have no common factors. If they do, you will need to factor them out. And the bottom, our denominator, cannot equal 0. So let's analyze this rational function. F of x equals x minus 3 all over x plus 2. We see that there's an x minus 3 in the numerator. That's a polynomial. It's specifically a linear function. And x minus 2 in the denominator. That's another polynomial, specifically another linear function. They have no common factors, and our denominator does not equal 0. Now, what do we know about denominators? We know that with fractions, our denominators cannot equal 0. So we need to take x plus 2 and set it equal to 0 because we need to find what is going to make this denominator equal 0. X plus 2 equals 0. By subtracting 2 from both sides, we get x equals negative 2. Therefore, our domain cannot equal negative 2. So, how does this relate to the function? This means it's an asymptote, meaning the function is going to get closer and closer and closer to this imaginary line. However, it is never going to touch it. Let's see what that looks like. Here we have a graph. Here we have an asymptote. X equals negative 2. Now, I have the asymptote dotted because I want you to know that it is imaginary. We understand that it is there. However, if you were actually to graph this function in Desmos, you will not see, or a graphing calculator, you will not see this line appear. Let's finish establishing the remaining portions of the graph. We need to plot points on the left side and on the right side of that asymptote. So if we're looking at the left side, if we're at negative 2, on the left is going to be negative 4, negative 3, negative 3.5. When we plug these into our function, x minus 3 all over x plus 2, we are going to get the following numbers. So when we plug in negative 4, we get 7 over 2, which is the same thing as 6.5. 7 over 2 is 3.5. I guess I accidentally wrote a 6 instead of 6 because there were 6 directly below it. Negative 3 is 6. And then negative 2.5 is 11. I'd accidentally written negative 3.5 earlier, but we want to get closer and closer to the asymptote. So when we go out negative 4 and then up 3.5, 1, 2, 3.5. And then we go out negative 3, and we go up 1, 2, 3, 4, 5, 6. And then we go out negative 2.5, and we go up 11. So our function is looking something like this, maybe. Now, we need to do the same thing on the other side. So now we have a negative 1.5, negative 1, and 0. Now, whenever we evaluate these three numbers, we get negative 9, negative 4, and negative 3.5, which is negative 1.5. So we need to plot these. Negative 1.5 is going to go down to negative 9. Negative 1 goes down to negative 4. 1, 2, 3, 4. And 0 goes to negative 1.5. So here is kind of sort of what our graph is going to look like. It's a sketch. We know that sketches are not completely accurate. They are just giving us an idea of what the graph is going to look like. Now, so that was pretty much it. Now, we could have done 5 numbers and we could have got more accurate, but as you recall, in the past, I've always required you to plot 5 points, and in this case, we have 6 because there's 3 on each side. Now, let's continue moving on. So, vertical asymptotes are what makes the denominator equal to 0. Okay, we can't get a 0 in our denominator because then our function is undefined. So it's a vertical asymptote because our function cannot be defined there. We have to talk about horizontal asymptotes. So there are 3 different possibilities. if the degree of your numerator is greater than or less than the degree of your denominator, your asymptote is y equals 0. If the degree of your numerator equals the degree of your denominator, your asymptote equals y over the leading coefficient of the numerator divided by the leading coefficient of the denominator. In the previous example, our degree of our numerator was 1, our degree of our denominator was 1, so we would be using scenario 2. And then 3, if the numerator is greater than the denominator, then we have no horizontal asymptote. Guys, this information needs to be written on a note card, something that you can access very quickly so that you can keep it straight. Now we're going to come back to oblique asymptotes in just a second. So let's look at our example here. We're going back to it. I noticed that the degree of my numerator is 1, the degree of my denominator is 2. So now I know for horizontal asymptote, that my degree of my numerator equals the degree of my denominator because it's 1 equals 1. Therefore, it's the leading coefficient over the leading coefficient. Our leading coefficients are 1. So that's going to be y equals 1 over 1, which is 1. Oops. So now we know that we have a horizontal asymptote. It's not a good color. There we go. We have a horizontal asymptote at y equals 1. It's still a little high. Let me draw it one more time. Nope, it keeps just picking it up. We know it's going to be a straight line at y equals 1 because I just told you. Now, here's the thing, guys. We can cross a horizontal asymptote, okay? We cannot ever cross or touch a vertical asymptote. There will be scenarios when you cross a horizontal asymptote. We may not have any of those right now, but that will be a scenario. Okay, let's talk about oblique asymptotes. When there is no horizontal asymptote, that's when you have an oblique asymptote. You may also hear it referred to as a slant asymptote. You're going to find it by using long division, and long division is your numerator divided by your denominator. And then your answer is going to be your asymptote. So let's look at an example of finding the oblique asymptote of the function f of x equals x squared minus 4 all over x minus 1. So I have my numerator, x squared minus 4, being divided by, hold on, I'm going to put place for an x. I'm going to account, just like with synthetic division, I'm going to account for every power of x. And it's going to be divided by my denominator. Now, what do I need to multiply x by? What do I need to multiply x by to make it equal x squared? Well, I can multiply it by x, right? Let's write that out. I can say x. I'm saying x times x, which is x squared, and x times negative 1, which is negative x. And then what I know is that I'm subtracting this. So x squared minus x squared is 0. And then 0 minus a negative x is a positive x. And then I need to bring down my negative 4. Now, once again, what do I need to multiply x by to make it x? It's already x, so I just need to multiply by 1, right? So I'm going to say plus 1. And this time, I'm going to say, trying to pick a good color, 1 times x is x. And 1 times negative 1 is negative 1. And remember, I'm subtracting these. And I'm going to say x minus x is 0, right? I don't even have to write that 0. And negative 4 minus a negative 1 is a negative 3. Guys, I don't even really need to worry about this. Not even worried about it. What I'm worried about is this linear function that is going to result as my answer. This is always going to be linear, because the asymptote is going to be a slant asymptote, meaning it's going to be a slant like this. Therefore, we can't have anything that's not linear. So we know that our slant asymptote is x plus 1. Right? Y equals x plus 1. So let's graph it. Okay, I've exported this graph from Desmos. Now it is time for us to graph the slant asymptote. So we know that our y-intercept is 1, And then our line is going to go up 1 over 1. I don't even have to draw it like that because I already made it. So we know our slope, our y-intercept is 1, and then it's up 1 over 1. So there is our slant asymptote right there. See, we get closer and closer to the asymptote, however, we never touch it. So those are the 3 different kind of asymptotes that you can have with rational functions. With rational functions, you will always have at least one vertical asymptote, maybe more. And then you will either have a horizontal or an oblique, but you cannot have both. All right. Whenever you begin your assignment, if you have questions, please come into the Google Meet so that I can help you and assist you work through the problems.